Greetings, M Squared here, and today we're going to talk about solving and graphing some inequalities. It's really important that you know what each of these symbols mean, and by that I do not mean the alligator is eating a bigger number. I mean, can you look at that sign and know that it is greater than and not less than? Do you know that greater than points to the right and that less than points to the left? If you don't know that, take some time to figure it out. I think the easiest way I've always told my students is that here you can see a less than sign and a greater than sign, kind of these arrows on a number line. The numbers are bigger over here, right? Greater numbers are over here. Less than numbers are over here. Smaller numbers, bigger numbers. So the greater than one points to the right, to the numbers that are bigger. The less than one points to the numbers that are less than. So take some time to do that, to memorize those. And then we have this addition of an equal sign under it, because sometimes things can be greater than or equal to. And a lot of times we use the word at least. Can you bring me at least 7 bananas tomorrow? That means 7 or more. 7 would work, or more would work, but not 6 or 5. So at least and at most. Bring me at most 3 apples tomorrow. That means 0, 1, 2, or 3. But 3 is included. So we want to make sure that we know that the equal sign means whatever I'm talking about, it also includes that answer. If it's just less than or greater than, it doesn't include those answers. It goes right up to it, but it doesn't include them. And then, of course, equals is not an inequality, but not equals is. Sometimes it can equal everything except one thing. So we could also say it's not equals to. So let's refresh our memory on how to graph these things. So x is less than or equal to 5. It doesn't really matter to me where you put your 5, if you put 0 in the middle. Sometimes the numbers are really big, so I just put it wherever I want it, and then I can just add a few other numbers if I want. I need to know that a line under it takes more ink, so a line that also takes more ink to fill in the bubble. But what that means is that 5 is included. And then it says less than. If x is on the left, the arrow points to where your arrow goes. If your x is not on the left, it's the opposite. So some kids get really confused on that. It says x is less than or equal to 5. Well, all of these numbers over here are less than 5, and that one's equal to 5. So that means I need to darken in the line because I'm including all the numbers where that is true. 7's not less than 5. Okay, we'll do this one and then we'll go back up there. So 15, okay, so I'm just going to do 5, 10, 15. You don't have to count by ones. You can count by 5s. Again, closed circle because there's an equal sign there. So x is greater than or equal to 15. So I like to mark my 15 down, and then if it still confuses you, think about a number that's bigger than 15. 16, 17, 20, 100. So that's all of these numbers over here. So one of the ways to graph is just to darken in that line and go that way. I'll show you a different way to graph on this one. So here we have a 4, so 2, 3, 4. I'm going to use an open circle because it doesn't have an equal sign. And then notice how x is not on the left? So this one says 4 is bigger than all the x's. Well, that means 3, 2, 1 are over here. So sometimes another way to graph is to just go up like this and make an arrow. So you're not darkening in the line, you're just showing the arrow up above it. And then plug a number in if you're not sure. Put a 2 in there. Is 4 bigger than 2? Yes, 4 is definitely bigger than 2, so that means I'm right. And then lastly, for this little example anyway, 7, 6, 8. So it says not equal to. That means the only thing it cannot equal is 7. So 7 is an open circle. And then you can darken in and arrow that way, darken in this way, and make sure you put your arrow so we know that it goes on forever. That's what those arrows mean. It goes on forever. If you don't have the arrows, that means it stopped. And usually that would require a circle. Okay, so a little review on that. Now I want to talk to you about, before we solve some more challenging inequalities, I want to talk to you about why we have rules for negatives when we're dealing with inequalities. So we're just going to do some things to this inequality, and we're going to see when it works and when it stops working. Add 2 to both sides. Okay, we're going to add 2 to both sides. What do I get? I get -1 is less than 9. Is that true? Oh, first of all, -3 is less than 7. I should have asked you, is that true? Yes, -3 is less than 7. Is -1 less than 9? Yes, Negative 1 is less than 9. Okay, now it says subtract 3 from both sides. Okay, so we're going to do something different here. We're going to subtract 3 from both sides. We're going to get negative 4 is less than 6. Is that true? Yes, negative 4 is still less than 6. Okay, we're doing good. Now we're going to multiply both sides by 3. That would be negative 12 is less than 18. Is that true? Yes. Negative 12 is still less than 18. We're going to divide both sides. So we've added, subtracted, multiplied, divided. Now we're going to divide both sides by 2. Okay, so negative 6, is it less than 9? Yes, negative 6 is less than 9. We're still good. Okay, so now we're going to talk about multiplying both sides by a negative. Watch what happens. All those things that we did, it kept the inequality true. Now we're going to multiply both sides by negative 5. Negative 5 times negative 6 is positive 30. 9 times negative 5 is negative 45. Look what happened. This side, what had been smaller the whole time, changed from negative to positive because I multiplied by a negative. This side went from positive to negative. So it actually switched the truth value. This is no longer smaller than that side. It's greater than that side. So the rule says that if you're multiplying or dividing both sides of an equality by a negative number, notice it didn't change when we multiplied by a non-negative. When we multiplied by a positive and divided by a positive, it didn't change. It was when we multiplied or divided by a negative number that it actually changed the truth value of that statement. And we had to change this to make it true. So that's why you have to be careful with inequalities. When you divide or multiply both sides by a negative, you have to change it. You have to change the inequality. It might not look any different for x because you can't tell. That's why I did this with numbers. We know that 30 is bigger than negative 45. If it was 3x is greater than 7, we might not know that. So let's try to solve and graph some of these. Okay, first step. Here we go. We need to get x alone. Then we're going to graph it. So we're going to add 5 to both sides. We're going to get 1/4 x. That cancels. Is less than 7. And now we need to get x alone. So we're going to multiply both sides by 4. So that gives me, that cancels out. X is less than 28. I didn't multiply by a negative, so I don't have to switch the less than sign. Here we go. We've got 24, 26, 28. Open circle because that was a less than, and going to the left because it says x is less than 28. So we have to graph all the numbers that are less than 28. And instead of going on forever and ever, we just draw the arrow to show that the solution goes on forever. All right, let's try this one. We got a lot of things going on here. So there's no fractions. Remember, we always check for fractions first. There's parentheses, so we're going to distribute. So negative 3x plus 4 is greater than or equal to 5x minus 12 minus 8x. That's what happens when I distribute that negative 4 across that parenthesis. Now I'm going to combine like terms. That's my next step. Fractions, parentheses, combine like terms on either side. No combining like terms happening over here, so I'm going to write that down. But over here, I've got a negative 8x and a positive 5x, which together gets me a negative 3x. Minus 12. So now I'm going to add 3x to both sides. Cancels, cancels. Both of them cancel. Sometimes when that happens, I go back and say, oh, did I do something wrong? And then I check, and I didn't. So then I know that my answer is 4 is greater than negative 12. Remember, when the variables cancel out, you always ask yourself, is what left a true statement or a false statement? So, is 4 bigger than or equal to negative 12? Yes, indeed. That means no matter what value of x I put in, it would always be true. That's all real numbers. So what I do is I darken in my arrows because everything works, and I just shade in that whole thing because my answer is all real numbers, and this is a real number line, so all real numbers. So that's how that works. Okay, let's try another one. These are our last two for this one. Okay, so we need to get all the x's on one side, all the numbers on the other side. I like to look at the side where the biggest x is and move that way. That way I avoid negatives. But some people like, when they do inequalities, to always have the x on the left, because then that tells you where the arrow is, and I'll show you how to switch that. So you could have done that too. Then you would have divided by a negative, but remember, we just have to switch our sign. So we're going to do that, put our x's on the right side. That means I'm going to put my numbers on the left side. So this cancels and this cancels, and I'm left with negative 18 is less than 2x. I'm going to divide both sides by 2, and I end up with negative 9 is less than x. This is the same as x is bigger than negative 9. Some people get confused there. If negative 9 is less than x, then x has to be bigger than negative 9. That's how that works. So you can switch these around as long as you switch that around. So we've got negative 8, well, negative 9, negative 7, negative 6. So we're going to put an open circle on that because there was no equal sign here. And it says x is bigger than that, so I'm going to go this way. All right, last one. 15x, getting rid of my parentheses using distributive property, plus 6 is greater than or equal to 8 plus 12x plus 7. That was the first step. I mean, we didn't have any fractions, so that's our first step. Combine like terms. Here's some like terms. So we have 15x plus 6 is greater than or equal to 12x plus 15. And now we need to get all our x's on one side, so I'm going to subtract 12x from both sides. And we're going to get all our numbers on the other side. So that cancels out and that cancels out. We're left with 3x is greater than or equal to 9. And if I divide both sides by 3, I get x is greater than or equal to 3. So I go down to my little graph, 2, 3, 4. It's a closed circle this time because it's got an equal sign. And it says x is bigger than or equal to 3, so that means I'm going to my right. Okay, those are some examples of solving inequalities. We avoided dividing by a negative because I put them on that side, and so you can do that too. But if you divide by a negative, you got to switch that inequality sign. All right, good luck. M squared signing out.